So this is talk about privacy, end user data privacy. So privacy has gotten a lot of attention recently, especially after the Snowden revelations last summer. But there are not a lot of technical people with experience doing privacy. So it's ending up that a lot of security people end up doing privacy. And this makes a lot of sense because a big part of privacy is securing the user data. But there are some other aspects of privacy also, and basically this talk is about those aspects. So in particular, I'll be talking about privacy by design. So this is a methodology that originated in the 1990s, and at this point, it's pretty much the most popular and regulatory approved way of doing privacy engineering. It's basically a set of principles, which we'll talk about in detail more, but basically most of them will make a lot of sense to security people, but there are a couple that may not be so familiar, and so basically in this talk we'll talk about those aspects. So as far as what we'll be covering, first I want to sort of describe or compare security versus privacy in a way to sort of emphasize why privacy is a little bit different. Okay, then I'll talk about personal information, or PII, because it's hard to talk about privacy and not talk about these terms. Okay, and then finally we'll get into privacy by design. So first, security versus privacy. So in the usual setup for security, right, there's Alice is communicating to Bob, and Bob could be a server or another person or even a hard drive, right, that you're writing to. And the usual setup, at least cryptographically, is that Bob, if Alice is writing one bit of information, the idea is that the attacker should not be able to guess this bit with more than 50% accuracy. Okay, if you've done that, then you've done a good job security-wise. So privacy, you still have the same basic setup, right? You have this attacker who's trying to snoop communication, trying to break into systems. But there are other entities you need to consider also. So these entities are not necessarily attackers in the malicious sense, right? But it's helpful to model them as adversaries because you're usually trying to limit the amount of information that they know, right? So I put Intel up here because I work for Intel, and if you're doing privacy, a lot of the time you're trying to sort of figure out what you can infer about the data your company collects about its users, right? So, okay. So, for example, we might want to try to figure out whether we can infer the identity of a user from the data we collect. And these inferences, right, are not necessarily too easy, right? So, for instance, a few years back, who would have thought that if you collect the browser user agent, the time zone, screen resolution, that with these kinds of data you can actually identify the device. So this is an example of the kind of inference that you can get from collecting data. Because of these kinds of inferences, right, which are often, machine learned, the tools of the trade for privacy are things like statistics, data mining, machine learning. And this is in addition, right, to the traditional tools of security, cryptography. Okay. So what makes the inference problem maybe a little harder, or maybe much harder, is that you often don't know what other knowledge the adversary has. So for instance, if you collect data that some user says he's at school, you probably don't know really where he is. But if you also know he's from Singapore and you know his approximate age, then there's probably a not so long list of places he might be, right? But if you also happen to know his sort of little region within Singapore, then you can probably have a pretty good idea where he's at. Okay, so the auxiliary knowledge that this adversary has kind of influences, right, to a great deal what kind of inferences he can make. Let's see. So, likewise, when you build a product or service these days, there are it's rarely in isolation, right? You're usually using other service providers or infrastructure providers or partners, and you have to understand what they know about your users too. So if you're using a Google Maps plugin, what is Google learning about your users, the location of your users? So that you should consider also, right? And finally, you have to sort of explain all this to Alice, sort of what data you're collecting, what inferences are possible. In security, right, remember that Alice is basically trying to communicate nothing to the attacker, and nothing is kind of easy to understand. But in privacy, you're trying to actually communicate some non-trivial data. So trying to communicate this to the user introduces, human-computer interface problems. It's more involved than with security. So this is a little bit of an exaggeration, this comparison, right? Because in security, there's also inferences you can make too. So for instance, even though you don't know anything about the content of the communication, you know when it was sent. So maybe on the basis of when it was sent, you can deduce things. But I would argue that the kinds of inferences, the inference problems, are at a greater scale with privacy. Okay, so that's enough about the sort of the basic setup and why privacy introduces kinds of new things to worry about. So now let's talk about personal information, or as in the US, it's often called PII, or personally identifiable information. Okay, so what is this? This is the Asian Pacific Economic Cooperation. Since we're in Singapore, we'll use their definition. Okay, any information about an identified or identifiable individual. So other organizations around the world will have similar definitions. They're all pretty much the same. What this means is things like, you can use biometrics, birth date, name, address, credit card number to identify somebody, and that any information attached to that identifying information would also be considered personal information, right? And an important point here is that it doesn't matter how trivial this other information is. It could be like you don't like ice cream, right? But once it's attached to some identifier, right, it's considered personal information, because it shouldn't be up to anybody to define what is personal to you or not, right? You may simply not want other people to know, your ice cream preferences or not. So the concentration on this idea of personal information is not on the kinds of data attached to these sort of ways to identify somebody, but on these ways to identify somebody, right? So these identifiers. So the problem is, if you think about this definition, right, you kind of realize eventually that there's some problems with it. What does identifiable really mean? So for one thing, the usual model you have in mind is somebody goes through the data that you collect from somebody and says, well, this is personal information, this is not sensitive, this is not. But that really doesn't work, right? Because whether something is identifiable to an individual depends on all the data. So if you consider device fingerprints, if you look at any of those pieces of data in isolation, it's kind of innocuous. But only if you take everything together does it actually identify somebody, right? So identifiable depends on all the data that you collect, right? Not just a few fields. Another thing is that it depends on what auxiliary data you have. So you may have the name and address. Okay, so that's clearly personal information. But suppose you have an identifier, right? And some data attached to that identifier. And that identifier is in some third-party proprietary database attached to a name and address. So presumably you don't really have easy access to this other database, right? So is that considered identifiable? I mean, somebody could identify it, right? But you can't, at least not so easily. So is that considered personal information? Unclear, right? So the argument I'm trying to make is that this idea of personal information, or PII, is a construct based in policy and law. It's not a technical construct. And technically, in fact, it doesn't make any sense. Okay, so for us, on the technical side, so I would encourage you guys to forget about, the idea of personal information. Let me just end this little section with a quote from Narayana and Ishmatikov. These are two sort of privacy security researchers. They're basically they say it better than me, right? So basically, people who try to go into a collection of data and sort of pick out what is considered personal or not is just not the right way to go. You have to look at all the data at once. Okay, if you accept what I'm saying, that personal information is sort of not exactly what you want to look at as a technical person, then what do you do about all your company policies about personal information or PII? Because, for instance, I work for Intel, and Intel has certain policies that you have to handle, PII in a certain way. And you have to treat it in a certain way. So how do you do that if you can't even define it? Well, here is one suggestion. You can take a risk management approach. So basically, the risk of a piece of personal information depends on how easy it is to make the identification with an actual individual and how sensitive it is, right? So together, you can sort of evaluate the risk of a certain piece of data. So if you know the risk of that data, then you can sort of compare it with other data of similar risk, and they should be handled the same way, right? So in this way, you might sidestep the question of whether you want to declare something as personal information or not. That's more of a legal policy issue, but more on a technical side, we just take a risk management approach. Okay. Okay, so now we've talked about this PII, or personal data question, which comes up when you do privacy. Now finally, let's talk about privacy by design. So privacy by design is basically a set of principles, and these principles were based on the Fair Information Practice principles, which originated in the 1970s. Back in the 1970s, the U.S. Department of Health, Education, and Welfare formed a small commission to look at the consequences of all this electronic data that was coming into being. So the commission came up with 5 what they call the Fair Information Practice principles. And let me just tell you about those, because they're actually pretty easy to understand, and they're very intuitive. The first one is that the user should know about the data collection. If you're collecting data from a user, you should know about it. The user should be able to see the data collected. So if you're collecting information from somebody, he should be able to come back to you and say, okay, show me what you've got. Okay. The data should only be used for the use that it was collected for. So usually you tell the user why you're collecting the data, and you shouldn't use it for some other purpose, obviously. The user can correct or amend or delete the data that you have on him. Okay, that's the 4th principle. And the last one is basically the data should be secure. In those days, they used the term reliable. But basically, you want to make sure the data is stored securely or reliably, and people can't just come in and misuse it. So those are the original fair information practice principles from the 1970s. So after a few years, there were other bodies, governmental bodies from different places, not just the US, but Europe in particular, which they took these fair information practice principles and augmented them a little bit, made them into policy and eventually law in a lot of places. So privacy by design builds on those principles. Okay, I won't go into all 7 of these privacy by design principles because you can easily find information about these on the web. Instead, I'm going to try to give you 3 sort of guidelines, basically on how you do privacy by design. Okay. So the first guideline is the data secure? Okay, so this is one of the key aspects of privacy by design. And as I said before, since this is a security audience, we probably don't need to worry, at least worry about this too much. But basically, this is whether the data flows that you're getting are actually the data flows you're expecting, right? So I won't say more about this one. This one, we're going to cover a few examples a little bit later on. But basically, have we minimized the data that we collect? And minimized means that we shouldn't collect more than what we really need. And that's a little bit hard in this day of collecting all the data you can get from somebody in order to maybe target an advertisement to them or something like that. But the philosophy is you shouldn't get more than you really need, and you shouldn't keep it longer than you need to, right? So after a certain amount of time, if it's not of any use, you should just get rid of it. Okay, so this is basically data minimization. Guideline number 3, does the user understand? So the word transparency you often hear with respect to privacy, right? Well, we are transparent. Well, what does that mean? If I'm sitting, if there's a window which is transparent but I'm not looking through it, it doesn't really help, right? So if a company has transparent policies, it doesn't really help if the user never looks at them, right? So I don't want to use the word transparency here. The goal is really to make the user understand what's going on, what kind of data is being collected, why it's being collected, and what the retention policy is, things like this. He really has to understand. It's not just that he is able to understand if he, does certain things. At least that's the goal. Okay, so let's talk about data minimization first. I'm going to give you 2 examples, all right? Then I'm going to talk about anonymization, which is kind of a way to do data minimization, right? You try to depersonalize the data by removing any trace of any particular person. So the first example has to do with IDs. So whenever you hear about IDs, it should be a red flag for you, okay? IDs and a couple other terms that we'll get to. So you should want to understand what is associated with that ID, because IDs are a way to glue information together, right? If you have an ID that's persistent for a user, you can attach data to that ID over a period of time, and eventually you get sort of a better picture of the user's habits and what he's like, what he does. IDs can be confined to one company or go across companies. So for instance, Apple's advertiser ID. Apple's advertiser ID, right, is meant to sort of be shared among a group of entities. And so that's kind of even more dangerous in a sense, because you've collected data corresponding to this ID, some other entity has collected data. If this data is ever merged, what inferences are possible is not clear, right? And so basically you would like to sort of disconnect the data whenever possible for privacy. So if you're trying to maintain privacy, you want your data in little pieces that are not connected. You don't want it all in one big lump that can be easily analyzed, right? So one example of this is Google's decision a couple years back to sort of merge all the data from its various services. And if you remember, that caused a big privacy uproar, right? People didn't like that because now all of a sudden Google has merged your Android data, your search data, and I mean any other data that you use from them into sort of one big pile. And so you can imagine that they get a much better picture of you because they merge this data. So that's the problem with IDs, okay? Now, I'll give you a simple example of data minimization with IDs. I was involved in a project where we were collecting data for troubleshooting and diagnostics from devices. Okay, there was a need to sort of correlate data from the same device, right, in order to sort of figure out what was going on. But the key point was that this correlation only needed to be local in time. So, for instance, if you collect data from the same device that was a week apart, you didn't really need to know it was from the same device. But if you collected this data, that it was an hour apart, then it was quite useful to know that this data came from the same device. Okay, so given sort of that need, what we did was we periodically changed the identifier, right? So we would upload data from the device with an identifier, and then every few days we would change that identifier. The device would change its own identifier. So in this way we get sort of this local correlation of what's going on. But we've sort of enhanced the user's privacy because we can't get, right, a long record or keep gathering data on the user. Because every sort of chunk of data that we gather about a particular user is only like a few days long. So in this way, we've sort of minimized the data based on our need. So that's a simple example of minimizing data. Here's another example. It has to do with location. Now, location is another one of those terms that if you hear it, your ears should immediately perk up and say, all right, what is going on with that? Location is very useful for mobile apps, right? But at the same time, right, it's one of the most sensitive things about your location. So the scenario is that there's a website or app that incorporates this. You want to use this third-party weather service. You don't want to go to the trouble yourself to build this sort of weather service, so you use a third-party weather service. This weather service, you give it a location, and it gives you back maybe the weather in that location, probably the forecast too. Okay. You can easily find a bunch of these services on the internet, right? Because it's obviously a useful thing. So you would naturally not give the user who requests the location, who requests the weather, you wouldn't give his user ID to the weather service, right? You would just give the weather service a location, right, unmarked with the user ID. And so the picture you get for the weather service might be something like this, right? He just gets a bunch of marks for some user requested the weather at this location. And you may think, well, this is okay. I mean, this should be okay. The question is, does anything like this ever happen? Does the weather service ever see something like this? Where the set of queries is sort of obviously corresponding to one person. And if you get the location for one person, you can pretty much, you know a lot about that person, right? You know where he lives because you know where he sleeps at night. You know his habits, what he does during the day. I mean, you know a lot if you can get his location trace. So the question is, does this happen? Can this happen with if you're using this third-party location service? I mean, weather service. intuitively, you might think, well, there's so many users, right? This shouldn't happen because, I mean, all the users' patterns will be sort of on top of each other, and you won't be able to discern any pattern like this. That might be true. How do we figure out whether it might happen or not? Well, let's look at an analogous sort of situation, Twitter users. So a while back, there was a demographic study of Twitter where they tried to figure out in each county in the US what percent use Twitter. So this is a scatter plot of what they found. So if you look at the bottom left-hand corner, there's a diagonal there. That diagonal, right, represents counties where there was only one Twitter user. So, in other words, the distribution of Twitter users is such that there are counties where where they're really geographically isolated users. And this is 3.2 million users, okay? So, this is some evidence, right, to argue that, you know, it could happen. If you're in some situation where there are not many users near you, right? And in Twitter, even in Twitter it happens, right? With millions of users. You might be in a situation where you're geographically isolated. And if you're geographically isolated, you might be tracked. So what do you do about that? Well, you can just make the observation that weather, right, doesn't really depend on your exact location. I mean, your weather only depends on sort of your course location. I mean, it's not going to change within a city too much. So maybe you don't need to give your exact location to the weather service. You give some sort of coarse, very coarse, maybe a grid coordinate or something to the weather service. And that's good enough for getting the weather, right? If you do that, then you've sort of reduced this problem of the weather service sort of tracking your users. So this is another example of sort of minimization, okay? Because you don't really need to give something, you try not to give it. Okay, so now let me talk about anonymization. Anonymization is this really attractive idea, right? You're afraid of this data that you have, you know, getting into the wrong hands or whatever. So to help with privacy concerns, you anonymize it. And then there's no problem. So for instance, Google and Yahoo, after a certain amount of months, they claim they anonymize your search data. And they don't exactly tell us what they do, but they've said something about, you know, you do something to the IP, maybe you truncate it, and then maybe some other things, but they really haven't said. But they claim to basically anonymize the search data. So this is obviously attractive from the privacy point of view. But, you know, it's non-trivial to do anonymization. And this is one, if there's a few points you want to take away from the talk, probably this is one of them. Anonymization is not easy, okay? And we're going to like see some examples in a sec, okay? But it's an important point. So let's take a look at location data. So if you just take away the ID from a location trace, obviously you can get the guy's ID, right? You know where he sleeps. You might have the thought, well, let's just cut away some of those points. You know, cut away where he is home, maybe cut away some other points, and maybe that's good enough. Last year, there's some researchers from MIT who looked at this mobile phone data set, about 1.5 million users. And they found that just 4 data points was enough to identify a user. So basically, your mobility patterns, or how you move around, is sort of a very identifying characteristic. So it's very hard, right, to just sort of remove data points in order to try to anonymize. You might have the thought to coarsen the data, like we did with the weather service, right? Instead of sending the exact, keeping the exact location, you just keep sort of a coarsened variation. You could do that, and it might work if you do it in a coarse enough way, all right? But you may lose why you're keeping the data in the first place, right? But I'll just give you one other sort of well-known result. Philippe Gollet and Kurt Partridge, I guess this was about 5 years back, they were looking at basically census data. And if you look at the zip code, when this is roughly, say, 1,000, 2,000 people, of where people work and where people live, so that tuple, right? That is enough to narrow you down into a group of 20. So in other words, in your zip code, there's probably, or there's likely, right, only 20 other people who also work in the same zip code. And this, of course, varies depending on, these are all basically median figures. But the idea is that, even when you coarsen data, location data, it's kind of hard to scrub away the individual characteristics of it. So location is kind of a hard thing to depersonalize. Search data. Okay, this picture here is from the New York Times a while back. You've probably heard of this, but basically a New York Times reporter managed to de-anonymize the data. It wasn't even a computer science researcher, right? It was just a reporter who looked at the search data and said, "Whoa, okay." Again, it's kind of difficult to. It would seem kind of difficult to anonymize search data, although Google and Yahoo claim they are doing it. Okay. And I'm going to give you a few more examples, right, just to drive this point home. Probably you've heard of, at least some of these. This example of Latanya Sweeney discovering the Massachusetts governor's hospital visits is another famous example. So Latanya Sweeney was a CMU graduate student, and the Insurance Commission of the state of Massachusetts released these anonymized, hospital visits, for the purpose of letting people analyze the data to make society better, I guess. Latanya Sweeney took this data, right, which had been anonymized by removing name, address, social security number, and she joined it with voter records. So voter records also had things like gender, zip code, birth date, but also name. And it turns out, gender, zip code, birth date is basically an identifier. So she was able to look up the governor in this set of records and see that he, visited the hospital. And that was kind of a famous de-anonymization case. Probably one of the first. Another example is the Netflix Prize Dataset. So this is a dataset of movie ratings that Netflix released. It's an anonymized movie ratings that Netflix released, I guess, in about 2006 or so, for the purposes of letting researchers experiment on them in order to improve Netflix's recommendation algorithm. They were offering like $1 million if you improved the recommendation algorithm by more than 10% compared to theirs. So it turns out, right, that you can sort of identify users in that data set because of the movies that they actually rated. Because the Netflix data set, like a lot of other data sets, it has a long tail, the set of movies. So if you choose if you're rating a movie in this long tail, they're not, relatively speaking, there are not many other users who have rated that movie, right? So it's kind of an infrequent event. So if you have a few of these infrequent events, basically you can identify the user, right? So this is what they call the problem of having a long tail, right? A few of those events is enough to identify somebody. And this got a lot of press because they managed to identify people who, in this other data set, this public data set, right, called the Internet Movie Database. This Internet Movie Database had associated usernames to it. And the Netflix data had movies that were not publicly rated. And sometimes the movies that were not publicly rated were kind of potentially embarrassing. And there was a lawsuit eventually that some closet gay woman claimed that from her Netflix ratings history, you can infer that she was homosexual. And these movies didn't exist in her public ratings, right? So eventually Netflix settled this suit, right? But this was another example of, why anonymization is hard. You would think a few movie ratings, what's the harm? But in fact, you can identify somebody from that. Finally, I'll give you one last example: graphical data. So graphical data, even if you take away identifiers from the structure of the graph, you can figure out, you can identify somebody basically. So if you have some auxiliary graph data set, say like Twitter or something that's more public, you can sort of map your users to those users to sort of identify them. And this is what people did. Okay, so that's enough about anonymization. I hope I've convinced you basically it's not a trivial thing, and you should be careful when you attempt this thing. Okay, so that was the whole point of all that. So I'm going to end this data minimization part by just saying that, you can see that the challenge in data minimization is that people on the other side are trying to make inferences through data mining. And data mining is getting, better and better as we go on. And there's more and more data. So the challenge is that we have to there's a tension, right, between data minimization and data mining. And this is sort of the issue in this area. Okay. Finally, there's the topic of does the user understand, right? This is sort of the last guideline on privacy by design. The traditional model or framework for privacy is that you sort of explain to the user what you're collecting, and all this, and he says, okay, he consents. So this is called the notice and consent, right? And often it's implemented by some, little privacy link, maybe on some web page you're looking at, and if you click on that link, you get something like this. And how many people have read Google's privacy policy completely? Right, not surprising. The font on this thing is small, intentionally, okay? Nobody reads these things, unless maybe you're professionally interested. They're mainly for lawyers and policymakers, right? So what happens is if the company doesn't follow what they say they're doing, then the lawyers and policymakers can say, hey, wait a second, you said you're supposed to do this, but you're not doing it. The end user is actually not really paying too much attention to this, right? Unfortunately. So the traditional notice and consent model is really difficult because how do you make the user understand? He doesn't want to understand. He just wants to do what he is trying to do. He doesn't care about your privacy policy, right? And that's why you should do everything you can in the area of data minimization. And because getting user understanding is very hard, right? So you should try to minimize the data as much as you can to sort of lessen the need for user understanding. Because user understanding is a very hard game. And usually, it's not real user understanding, it's more something so that the lawyers and policymakers are happy. Okay. So just to say a little bit more about, or give an example of why this is hard, I'm going to talk about actually an Intel project called the Perceptual Computing SDK. So this is a bundle of sort of algorithms and drivers that Intel has put into a library, and it can enable third-party developers to do things like, measure your heart rate. So using the sensors on your webcam, it can pick up the minute fluctuations in your skin tone with every heartbeat, and in that way sort of measure your heart rate. So it enables applications like that. But of course, these sorts of applications have privacy concerns, right? Because it may not be just things like measuring your heart rate. They may be capturing raw video. They may be doing facial recognition, things like this. So the problem is, how do you make the user sort of understand what is going on? What is the application actually doing? One thing you can see here is icons. So what is the first thing that people do when they see one of these, privacy notices or EULAs? Well, they quickly search for the OK button or I agree button, because you just want to get rid of that thing, right? So while they're doing that, maybe in this case, they see some pictures, right? They probably aren't going to read anything, but if they see some pictures, then at least pictorially, you can sort of see some indication of what the app is doing. So this is sort of one thought here, to use sort of pictures or some other ways to get user understanding. Another point that I should mention is that at the bottom of that dialogue, there's a little unchecked box for giving the app permission to share your data. So it's unchecked, right? And that's important. There's a principle of privacy by design called private by default. If the user doesn't do anything, right, he should maintain his privacy. And that's important, right? Because most of the time he's not going to do anything, right? So it's similar to fail-safe in security, right? If something fails in security, or the user's not paying attention, you want things to still be safe, right? So you still want things to be private if the user's not doing anything. This is interesting what this means in the case of something like Facebook, right? Where if you can't have absolute privacy by default, because you would not communicate with any of your friends or anything, and users would not necessarily know to go in and change those settings. So they can't exactly adopt this, right? But the idea is this is what you should strive for. You might notice the similarity of, this set of, sensor data and what you're doing with it to Android permissions. So when you install an Android app, right, you get this sort of long list of permissions. It's sort of like a privacy notices and URLs. Most users don't pay any attention to it, right? You just scroll down as fast as you can and just click that thing, right? Because this thing is getting in the way of you installing the app, right? Users are not here to try to analyze the privacy ramifications of this app. They just want to install the app and do what, right? So, given that, what do you do? Well, there are some approaches people are looking at. So, for instance, some contextual approaches. So instead of, in the very beginning when you install the app, and the user is very unlikely to be paying attention at that time, right? You sort of ask for permission only at the time you need it. So if you are getting location data, for instance, then maybe you only ask just at that time. And there have been some studies which say that might work a little bit better. But obviously, this is a really young field, and I just want to convey that right now things are in probably a sorry state, right? It's sad to say, but there's a lot of work people are trying to do to try to make it better. But how much they can make it better is unclear. So just to sum up, right? we've looked at a couple aspects of privacy by design. It's now the sort of the de facto standard for privacy engineering. Most of it, it's because we're security people, is sort of very comfortable, but there are some aspects that are a little maybe less comfortable. The two aspects that are maybe less comfortable are data minimization. For data minimization, emphasizes machine learning, and this is going to get more and more important, right, as big data and as the size of basically big data grows and more data is going to be collected about you, right? So this is more important. Another aspect of this is user understanding, right? User understanding, it emphasizes the human-computer interface. And this is going to get harder too, right? So we're moving into a world of mobile and Internet of Things. And in this new world, how do you get notice and consent, right, from a sensor, a street camera? I mean, the models are unclear, right? So this is another area, I think, that will deserve a lot of attention in the future. Finally, I want to say that, I didn't cover a lot, okay? So there's a lot of privacy topics that are kind of on the side, like children's privacy, all right? And the fact that, different regions of the world have kind of different privacy laws, and how that all plays together. So when you do these things, especially for user understanding, you probably want to consult your privacy lawyer in your company, okay? So they will be able to give you guidance on what your design, whether it actually is okay from the legal point of view. Okay, so it's just a sort of a mini disclaimer there. Other than that, thanks. And if you have any questions, I'm happy to try. Yeah.
What are the industry standards available to handle the AI? Like we have for the credit card, we have PCI. So what are those and how it is influenced by the region-specific policies?
Right. So there are legal. So there are legal sort of a policy accepted. It depends on the region of the world you're in, right? So depending on the region of the world, they might define, and this is not technical. This is more policy and law about what constitutes personal data or PII, right? So in the U.S., it's a little more loose. In Europe, more things would be considered personal data, but that's just a general statement. But again, I think I want to recommend from our point of view, at least on the technical side, it's hard to get involved in that kind of thing. I prefer to let the lawyers handle it and say, well, this is the approach. Is it acceptable? And if they should sign off on it, right? Uh-huh. Go ahead.
So you mentioned that in terms of IDs, you mentioned the technique where we can disconnect the data and change the ID over a period of time. So how do you decide the time window when to start changing the ID? Because even 1 hour of time frame may or may not have a difference. So are there any metrics to decide this?
Yeah. It depends. In that example, it depended on the technical need. So for that project, the kind of data that we collected, it was sort of acceptable to change it every few days. So for other kinds of data, it would be different, right? So it would be driven probably by the user of the data. So the privacy person, obviously would be pushing for a smaller interval, but they, might need a longer interval. Yeah. Are there more questions? then I guess we can break for lunch, right? Thanks.